Okay, so here's our second video on infinity. Now here's a surprise. 1, 2, 3, 4, 5, 6, I said that was the first infinity. And now I'm going to look at a set of numbers that's just the powers of 2. Okay? This one looks like it has
way less.
Many numbers missing from this one, right?
In fact, the number of numbers missing get bigger every time.
Yeah. So I wonder if this is the same size. Now I already gave the answer away because I said this is the smallest infinity. But this is also infinite, so it must be that they're the same.
Yeah, but we have to find a way to prove
Let's see if we can figure out how to go from here to here, and then how can we go from here to here. So how can I go from the integers to the powers of 2?
Well,
anyone have any ideas?
probably 2 to the something that's going to be involved.
Word is erasing. Yeah, 2 to the something. So I start with an integer like, let's say 3, and I want to send it to where?
4.
I'd like to send it to 4. You don't have to send them in order, but it's nice if you can. So I'd like to send 3 to 4.
Well, 2 cubed is 8, not 4.
Right, 2 cubed would go to 8, not 4.
If we just do 2 to the x, we're missing 1.
Okay.
Because 1 goes to 2, 2 goes to 4, 3 goes to 8.
Well, that's actually still fine, by the way. If you want to send 1 to 2, 2 to... That meets the 1-to-1 idea. One number goes to one number this way.
We're missing 1.
Right, we missed 1. I didn't tell you had to hit all the numbers. I just said you had to go 1-to-1 this way and 1-to-1 back. Okay?
Yeah.
So that would be sending 3 to 8 and 4 to 16 and 1 to 2 and 2 to 4 would actually still be fine.
But
According
if we
to
can
Cantor.
include all the numbers, that would be better.
Okay, that's fine. How would you include all of the numbers?
Well, we need one less because 2 squared is 4.
2 squared is 4. So if I take my number x, where do I want to send it to?
Well, 2 to the x minus 1.
2 to the x minus 1. Okay. Now, 2 actually goes to 2 squared.
Which is 4.
2 squared minus 1. So 2 to the 2 minus 1. Oh, I shouldn't write it up there. 2 to the 2 minus 1, which is 2 to the 1, which is 2. And now your map works the way you were hoping it would work.
Yeah.
Okay, so we found a map that actually goes and hits all the numbers. Okay, how do I go in reverse though?
Well, we need what are the opposite of powers?
Yeah, what is the opposite of powers? Interesting question.
Well, negative powers divide.
Well,
they also divide.
Fractional powers are square roots and different square roots.
Yeah.
We could do it that way.
We could do it that way. Gotta think. How can we go from this list up to this list?
Well, if we took the square root, we need to take out 2. We need to take out 2 to the. We need to take out something out of that to get back to that.
Yeah. What is it, though? What is it that we're taking out?
Well,
Maybe if you could write this list in a different way. What would be a different way you could write out the same list?
Well, you could say it's 2 to the 0.
2 to the 0.
2 to the 1.
2 to the 1.
2 squared.
2 squared.
2 cubed.
2 cubed.
2 to the 4th.
2 to the 4th.
2 to the 5th.
2 to the 5th.
And all the way.
Does that help you see what you might want to do?
It's the powers are the numbers except for that 0.
Okay, so how do you fix that? You let your brother answer.
well, you have to add. You have to add one. You have to add the number. You have to add another power.
Okay, so in this one, 2 to the x in our list goes to what number?
2 to the x goes to x plus 1.
X plus 1. That's our map that goes back. Does every power go to a different number?
Yeah.
Yeah? That's cool. So this list has the same infinity as this list because I could go back and forth.
Yeah, but it seems like it's way less.
Seems like it's way less. Okay, now are you ready for an ultra surprise?
Yeah.
All right. Here we go.